All right, so this is the Unit 5 review. So we're going to use this graph to help us identify everything below. So let's take a look at some of the first points. So this point right here is at -1, 9. This point right here is 0, 3. This point right here is 1, 1. All right, so we can see this is an exponential function. It's going to the left and it's approaching an asymptote right here. The domain, we can see goes all the way to the left, all the way to the right. That's going to be all real numbers. And you can also write the symbol instead. The range. So we can see the y values are going up, 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 up. So it's going up towards infinity. However, it essentially flatlines over here as it approaches 0. It does not equal 0 because 0 is your asymptote. So it's just y is greater than 0. Okay. The asymptote is the line that it approaches. It's this x-axis right here. So the asymptote is going to be y equals 0. Our y-intercept is going to be where it crosses the y-axis. So we could see right here, this is our y-intercept. So it's going to be 0, 3. Increasing or decreasing. We can see as we go left to right, just like we're reading words, right? Left to right, we can see it's going down. So that would be decreasing. We can see the y values going down as well, which indicates decay. So our equation, we're going to stick with our parent function, y equals a times b to the power of x. A is our initial value, which is also our y-intercept. So our y-intercept is 3. Okay, our b value is going to be the number that it multiplies every time. So to go from 9 to 3 to 1, essentially we're dividing by 3, which is the same as multiplying by 1/3. So 1/3 would be our b to the power of x. Okay, any questions? Okay. All right, so let's take a look at our function over here. Domain and range are actually going to be the same. So we have all real numbers, which I'm just going to shorten with the symbol. Y is greater than 0. As we can see, it's approaching the same asymptote of the x-axis. So my asymptote for this one is going to be y equals 0. I have a point here, 0, 5. And I have a point here, 1, 10. So we can see that is our y-intercept. So it's 0, 5. As we're going left to right, we can see that is going up. So that would be increasing. We can also see the y values are increasing. So that would be growth. Sorry, that got cut off. So increasing in growth. Our equation, remember, it's y equals a times b to the power of x. A is our y-intercept, so y equals 5. To go from 5 to 10, I multiply by 2. So that means that my b value is 2 to the power of x. Any questions on that one? Okay. All right, so this one is pretty much doing it all over again. So domain is all real numbers. Range is y is greater than 0. Asymptote is y equals 0. This y-intercept is right here. That's 0, 1. I can see left to right, it's going up. So that would be increasing, which is also growth. This is going to be 1, 2. And this one right here is going to be 2, 4. Okay, so I can see the y values increase by 2 every time. My starting value is 1. So it's going to be y equals 1 times 2 to the power of x. You can also simplify this. Y equals 2 to the power of x.
Well, if it's always increasing, will always be growth and then decreasing decay.
Yes.
And
yeah.
Then when it says the power of x, it'll always just be x, whatever number.
If it gives you a value, so if it says find when time is blah, 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 or find the value of the house after 5 years, then that's when it changes. But only if you know your value of x. But if it's just for the equation, you just leave it as x. Yeah, great question. Any other questions? So if it's decayed, the value inside of the parentheses is less than 1. Because that's a great question. So if you look at the decay right here, so see how this is decay? So see how it's still greater than 0, right? So all that the decay is saying is that it's going down instead of up. All of these have the same range of y is greater than 0 because they don't go below the x-axis. When you get to algebra 2, you'll start to see it change a lot more when you start to do transformations. But you can see all of them for right now. They're just approaching the x-intercept. Yeah, great question. Any other questions? Okay, I'm going to move on to the next page. Okay, so it says for the following situations, determine which are growth or decay. Circle the word or phrase that helps you determine which one it was. So the word I'm going to look for here is half are eliminated. So that means half are taken away. So that one's going to be decay. So $18,000 depreciates 25% each year. That's also going to be decay. Growth of bacteria, and it doubles. So double means increase. So it is growth. So that's going to be growth. Value increases by 3% each year. That's going to be growth. Okay. Any questions on identifying the word problems? Okay. Okay. Okay, so you take out a loan to buy a new Toyota Highlander. The value, and it gives you the cost of the car. So this is your initial value, so that's your A. Okay, then it says the value of the car depreciates. So that's the key word that we're looking at. The word depreciates at a rate. Decreasing means decay, yes. So when we have percents, we're either going to add it to 100% or subtract it from 100%. So do you think we're going to add this to 100% or subtract if it depreciates? Subtract. So it's going to be 100% minus 19%, and that gives us 81%. So there's two ways you could go about this. If you have 81%, you can move the decimal over 2 places. So that's 0.81. Or if you prefer to do it, let's say in Desmos, it's 81% out of 100%. So you could type in 81 out of 100, and that would give you 0.81. So this right here would be our B value. So B equals 0.81. Okay. So I'm just going to scoot down to where it says equation. Oops, let me zoom out a little bit. Okay. So our equation is going to use the just our parent function, y equals a times b to the power of x. So y equals a, which we said was our initial value, 38,580 times our b value, 0.81 to the power of x. Okay, any questions on this one right here? Yeah. Okay, so when we're looking at our next one, we want to look at our initial value. Our initial value comes from our y-intercept. Is that still fine? Okay. The question just says write the equation for the table. So our A value comes from the y-intercept. So my A is equal to 4. Okay. Just kind of like how we did on the front page with our y-intercept, but we were given the graph. Okay, and our B value is a number you multiply by every time. So if I go from 4 to 16, I multiply by 4. 16 to 64, multiply by 4. 64 to 256, I multiply by 4. Okay, so my B value is also 4. Any questions on how I got A or B? Okay, so it's going to be y equals A, which is 4, times B, which is 4, to the power of x. Also, you could have thrown this into Desmos and done a exponential regression, but the numbers aren't that complicated, so you can do it by hand. All right, so let's go ahead and go on to the third page. All right, so our A is our y-intercept. So if you look right here, my y-intercept is 5, so A is 5. And going from 5 to 2.5, and 2.5 to 1.25, and 1.25 to 0.625, that's dividing by 2. However, we can't divide by 2. We have to represent as a fraction. So we would write that as multiplying by 1/2, which means my B value is 1/2. Okay, any questions on that? You could have also put that in Desmos, okay? So that's y equals 5 times 1/2 to the power of x. Okay, so the population of a small town is 2,100, so that's our A value, that's our starting value. Okay, and then it says it increases annually by 2.5%. Okay, so am I gonna add that to 100% or take it away from 100%? Add it to 100%. So it's going to be 100% plus 2.5% gives me 102.5%. So once again, you can either move the decimal place over 2 times, so like this, or you can put it in Desmos as 102.5 over 100, and that gives you the same answer of 1.025. Okay, so my B value, so whether you did it by moving the decimal or you did it by division, you get 1.025. So my final equation is going to be y equals 2,100 times 1.025 to the power of x. Okay. Any questions on number 8? Sure. Great question. So see how it says increases by 2.5%? So whenever you see percent, you're either going to add it to 100% or take it away to 100%. Because of this word increases, that's why I added it. Once I got this percent right here, there's 2 different directions I could go. I could either move the decimal 2 places over, or I could divide it by 100 and then get the decimal that way. So whatever your preference is, you can choose. I'm going to scoot it down just a hair, okay? Okay, so I'm going to start reading number 9. The accompanying table shows the value of a car over time that was purchased for $12,900. X is the years, Y is the value of the cars in dollars. Write an exponential regression equation for this set of data, rounding all coefficients to the nearest thousandth. Okay, that's 3 decimal places. Okay. So what I need to do is I need to place this table inside of Desmos. So I'm going to go to my Desmos. Make sure you're in the Texas version to keep it comparable. Do plus table, and then I have 0, 1, 2, 3, 4. On this side, I have 12,900. Don't put any commas, or else it does not like that. 0, 7, 4, 9, 0, 9, 5. 6, 8, 2, 4. Okay. And then you're going to run the regression over here. And we are dealing with exponential functions, so you're going to change it to exponential. And it said to round it to the thousandths place for our coefficients. So just for the sake of the screen recording, 3 decimal places be right here. So I would use this 9 to round that up to a 3. And then I would use this 6 to round this up to a 7. So that's going to be your equation right there. Y equals 12,833.413 times, and I'm going to put that in parentheses, 0.817 to the power of x. Okay, so does this represent growth or decay? So just by looking at the table, is that growth or decay? Decay.
Wait, what is the number after the decimal point of the equation?
413. Okay, how do we know it's exponential decay? Yeah, so we know for 2 reasons. One, so we have 81.7 remaining value. So that's about 82%. So it decreases by about 18% each year. And that's just rounding. It's going to be 18.3, I think. So it decreases by about 18.3% each year. Another way we can see is the Y value is decreasing. Okay, so now this is asking, use this equation to determine the worth of the car after 9 years. So that's going to be, if we take a look over here, that's going to be our X value. So that's when our X value is 9. So honestly, you could just plug 9 into that table that you have. So go back to your Desmos. We'll just use this equation right here. So settings, create a table with our rounded one. And then I'm going to place the number 9 in. And that gives us $2,081, and that would round to 33 cents. Okay, so I'll put that back on the screen. So $2,081.33. Any questions on number 9? Okay. Okay, so let's go ahead and hop over to number 10. Okay, so the accompanying table shows the bacteria present in a certain culture over a 4-hour period, where X is the time in hours and Y is the number of bacteria. Write an exponential regression equation for the set of data, rounding all coefficients to the nearest thousandth. Okay, so let's go back to Desmos. I'll just delete everything I had. Start fresh with a new table. And I'm just going to put in the table that I see. So 0, 1, 2, 3, 4. 1, 9, 1, 2. Okay. All right, so then I'm going to run a regression, change this to exponential. And then, so I'm going to bring it down here, round it to the nearest thousandth, which is going to be 3 decimal places. So 1, 2, 3, that does not increase or decrease. 1, 2, 3, this 9 will round this up to the 8 to a 9. Okay, so this is going to be our equation. So y equals 1947.502. And I'm going to do a parentheses instead of the dot just to kind of keep it a little more organized. 1.179 to the power of x. So I'm going to go back to my camera. And then you can see right there, that's our equation. All right, so it is growth. So kind of similar before, I could see that if I move the decimal places over 1, 2, I'm at 117.9%. So we know because this value is greater than 1, we have a 17.9% growth every hour. But even more on a simplified terms, you can see the y values are increasing. Okay, so we need to know the number of bacteria present after 13 hours. That means x is equal to 13. It does specify round to a whole number. So you could just type this in. You don't need the y equals. You could type this in with x being 13, or you could just let Desmos put it in the table for you. So if I'm here, do my settings, table, I create a y value, I create an x value of 13, and I get this number right here. So I have, rounding to the nearest whole number, I'm going to get 16,564. So right here, 16,564. Okay. Any questions on that one? Okay, so at this point, you can do a self-reflection. So you can decide on a scale of 1 to 5, 5 being you're doing great, 1 being I still have no idea what's going on. Please give yourself a self-reflection of where you are at.